Yesterday, I streamed for 7 hours straight. Just a little break in between, and I don't think I will ever repeat that. That was insane. I'm sorry. Uh, it hurt my voice, it hurt my butt. Overall, not a good experience. But on the bright side, I churned out a lot of code, and I think we're in a very good position now with this Game Boy assembler. So let me switch to Windows real quick. So we finished implementing. I always say we, as if I have a team here, or I'm some kind of royalty. I don't know. Anyways, uh, I have finished the symbols table and actually been adding all the operation types in there. So operations can now be recognized as a token. And I have also, almost said we again, I have also implemented the first operations that have been written to the output file, to our ROM. Whoa. This file seems to be closed. There we go. This is our output ROM. It doesn't have headers yet or anything fancy. We have not even discussed about the region before the headers, right? All it has is, well, after the headers, some code is supposed to start, and here we are. These are the operations that can officially be written now. So that's cool. We have some sort of thing that if we would give this to the Game Boy, it would somewhat understand what to do. Well, I'm saying that, not quite, because in the header we need to specify the starting point of the ROM actually, because the real starting point is right here in the header. So usually we would have to put something in here that says, okay, let's start at location 150 hex, right? And then it would start here. But those are details for later. For now, I'm just trying to get things written into the ROM. Okay. One thing that I need to do now, which I made a little note here, is fail when there is unexpected tokens after a valid one. So what does that mean? So we have a bunch of valid tokens right here, right? And since they don't expect any arguments whatsoever, you could add a comment afterwards. That is just fine. That is legal code, right? Or even right after this. However, what should be illegal to do is RLCA, right? So what if I write this operation twice? And what if I write one operation and then a completely different one, right? Or I write an unknown word in here, right? Our parser will just happily pass that. But this is illegal because in assembly source code, it's, well, I mean, nothing stops you from allowing that, but it's just way easier to read if you have one operation per line, because then you can kind of, reason about how big the ROM will be based on the line numbers and all this kind of stuff. So, and let's put it this way, this has been kind of an agreed upon convention for assemblers for a very long time. So assembly source code listings always have like one operation per line. So let's just follow that. I think it makes sense, so there's no reason to just arbitrarily change that suddenly. Okay, so let's say I put RLA in here, right? What will happen? Well, nothing breaks. Actually, let's... Let's comment those out. Right? And let's just have those two statements right here. So now let's look at our output file. And indeed it works. 07 and 17, right? So 07 for... oh dear. RLCA. and an RLA. So RLCA is 07 and RLA is 17. So how would we stop this? Well, once we process an operation right here, we kind of want to make sure that there's nothing else following it, right? And let's see, what are actually valid tokens that could follow afterwards? So white space certainly is allowed because we don't care. Comments are allowed and new lines are allowed. Anything else? Well, oh, and end of line, of course. Let's not forget that. But if there's any other symbol or whatever else we might get in the future, that should not be allowed. So, right, I think we can just write a little function because we might have to use that for multiple things. And so if we encounter an end of line, we can be sure there's nothing afterwards. If there's a new line, there won't be anything afterwards. If there's a comment, I mean, the way we have written it, there can't possibly be anything afterwards. So that is fine as well, and we just return. If there's white space, there could be something afterwards, right? It could be one of these. So these are basically terminating statements. And now we just want to make sure there's only terminating statements as well. Well, or white space. Okay, let's write a little thingamajiggy here. So let's say void TBA. What do we call this? Instead of process token, I would name that parse token because this is essentially what we're doing now, parsing, because we have tokenized everything. So now the parsing process starts. So GBA, validate end of line. That sounds like a good thing, right? So GBA context. In last stream, we made a little context struct that we can pass around to make this kind of parsing a lot easier. And what we have is the token index. So we're getting the token right here. Then we go on to process operation. And we write directly into the output file. And what do we want to do after that? I'm thinking, do we want to, advance the token here? So let's say token index plus plus. And say return true. I mean, we don't have a failure mode just yet, but there might be later on when we're validating arguments and such. Yeah, I mean, we officially consumed that token, so it makes sense to advance it now, right? But then, now we kind of switch tokens up there, so... Whoa, I forgot I had an alarm on. As always. Okay, let's not advance the token just now. Um, hmm. Oh, decisions, decisions. I hate to make them. um, I mean, ideally, what we should do, we should call this from in here, right? We shouldn't call this on the outside. So in that sense, we probably should advance it. So, okay, let's do this. Context, token index plus plus. And then what if this is the last token? Can that ever happen? I don't think it can. Okay. Let's not think about it too long. So let's just do this. And actually, let's return whatever the result of this will be. So we're just switching over to a new state, which is validate the end of the line, right? Then we can have a bool here. And what we're doing here is basically saying for, we can just copy this for loop right here, to be honest. Where we check the token index, we check that it is still smaller than that. And if it is, we're gonna analyze that token and figure out what type it is. Now, if it is any of these, end of file, new line, and comment, actually these, we are golden. We are done. If it is a white space, we're gonna skip to the next one and try to figure out what's after the white space. And if it is anything else, oh boy, we are in trouble. So, now the question is, how do we report this? Let's try and make sense of some error messages. What do we have here? So if the symbol name is not recognizable, what we're doing is unknown symbol in line so and so. Okay. I wonder if I should have like an report unexpected token thing, like GBA print unexpected token error, right? And then we can do it this way and say we have a GBA token T token, and then this would be token type. And then once we have an unexpected token, it would be nice to just write about that token. This is the unexpected token, and we are gonna be in some specific line, right? Um, so, uh, yeah, let's just take this. Unexpected token. Well, what kind of token do we have? Let's see. We can do a wchar t and call this token type, right? And we can have a little switch where we take the token and we look over the type of token. Actually, we do not even need to do that. I just realized. We can use this little thing right here. So this is unknown symbol. I was thinking we can just print out the token name, but actually no, for certain token types we don't want to do that, right? So let's let me get all the token types that are possible. So these, and then, whoops, where was I? Oh shoot. Okay, so we have the token type. Let's say if it is end of file. No, that can't ever happen. So symbol and separator are the ones that can actually go wrong. So let's do that, right? Let's write this out. I was trying to kind of factor this out a little bit and make this like generic for any use case, but that's not what we're trying to do here, right? We want to print specific error messages, so let's do that. Let's not skimp around here. So what we can do is, if we have a separator, we're gonna say unexpected separator token, comma. At the end of the line. No, just say in which line it is, right? So LLU. And then the line is gonna be context, line. Cool. So there we are, printing out error messages like a hero. Okay. And then we have the same for symbols. And with symbols, we can kind of steal what we've done here for the symbol error, and that actually makes sense out now to refactor. to factor out, because now we can just say void GBA print symbol error, right? And this is going to be GBA context T context, and we want the symbol, which is based on the context and the current token. Okay, so we are going to steal this. Right, we have this buffer. Then we have, okay, the current token needs to stay there. That is fine. What's the dumbest way to factor this out? Well, let's see what we need, right? So let's steal this, because this is what we need to print out the error. So convert to UTF-8 16. So this is our destination buffer. We have max symbol name +1, exactly. And then we have the symbol name and the symbol length. So really, we do not need to pass the whole context in there. What we really want is const u8 symbol name, symbol name, and size t symbol length. And size t line. Okay, so we have symbol name, we have symbol length, we can say unknown symbol, blah blah blah, inline, blah blah blah. Cool. So we just change this to line. There we go. This is our print symbol error function. Now this convert to UTF-16, I mean, this only happens when we print out an error, right? This is maybe a good time now where we can put those things into separate header files. So let's say this is in new item. Header file. And this is gonna be GBA. So what do we have? We have a symbol. Well, I mean, technically it should be in symbols, right? Because it is a symbol error. Or should I put error messages all in one? That's the question. So we do not have error messages in the buffer file, which is fine. In file, we also do not print error messages, right? In symbols, I think I also do not. Yeah, I kept it all fairly simple. In token itself, I also do not print error messages. What's that to do here? Ah, right. Unicode. We do not worry about Unicode right now. Okay, let's make a new header for just error messages. New item header gba error.h. Okay. GBA assembler error. Whoop, error. And another error. Whoa, one R too much. And we're gonna put, what are we putting? Convert to UTF-16. Bam! Okay. So we want to include a few things. We want to include typedef and possibly stdlib and stdbool, right? No, we do not need stdbool because we need Windows anyways, because I want to put the Windows error messages in there as well. So we're going to say include, include, there we go, Windows, hello, there we go, Windows. Just import the whole word for Windows. There we go. Cool, so there's our Windows error message. Std is undefined. Of course it is undefined because we need stdio.h for that to work. There we go. Fantastic code. I'm gonna tell my grandchildren about this one day. No. And then we have GBA print symbol error, which can go right here. Okay. Max symbol name. Where's this from? It is from symbols, isn't it? Okay, hang on. So include string.h, I think we need as well. I'm not sure. Do we? No, I mean, everything is... Okay. Import project headers. What do we need? I kind of hate that max symbol name is defined in symbols h. But whatever. GBA symbols h. There we go. So we have the max symbol name as well. Huzzah. So what we now can do is get rid of these. And now we just include GBA arrow.h. All right. Sorry, I just had to check something on the other screen. I installed a new plugin on OBS and I was hoping it would show me the time of how long I'm streaming already, but it doesn't, so I'm just going to switch over to the stream manager so I can see the session length. Okay, 40 minutes. Right, so we've factored out the error stuff. to here. Okay. So now whenever we have a symbol that we don't recognize, we can have the error right here. So we want to say GBA print symbol error. We have the symbol name, the symbol length, and the line, which will be in context line. Sweet. Okay. So, and now we kind of want the same code. So these two lines up here. So this is when we validate the end of line, where we do not expect to have a symbol afterwards, but there could be still one. So let's just do token, right? Again, if we have a token type of symbol, we're trying to be user-friendly and print out the actual symbol that is wrong here. So we're just gonna retrieve the symbol name and the symbol length, the same as we did down here already. And then we're just gonna say print GBA print symbol error. Except the messages are slightly different, aren't they? So one is an unknown symbol, and the other one is an unexpected symbol, or an unexpected operation, for that matter. You know what? Let's do const wchrt error type, and then we can here say %s error type. Okay, bear with me. So now we can say down here unknown symbol right, and up here we can say unexpected symbol. Except maybe we want to distinguish between what kind of symbol it is, right? So we could have a quick like so, where we just say error type, and we have a switch over the token type. No, we already know the token type. Well, we would have to figure out the symbol. I mean, we have all the information, so I might as well just try and fetch it, right? Okay, let's do that. Let's do the same thing. So we're trying to look up the symbol. If the symbol is not here, but it's still just an unexpected symbol, and I'm just trying to figure out whether it's an operation or not, right? That is nonsense. That is way too much work for just an error. Okay, scratch that, forget about it. We're just gonna say unexpected symbol. And in that instance, we return false. And there is no default case. I mean, we could make this one the default case, so when we add new stuff, it will just be reported as unexpected symbol. Yeah, let's just leave that in. Why not? So this is validation end of line, where we make sure there is no more stuff after our operation. Okay, and then we call this down here. So we write out the operations, and then we advance the token by 1, and then we make sure we have a valid end of line, essentially. Okay, so let's switch back up to process tokens. I want to quickly rename that to parse tokens, because that is what we're doing. We're starting the parsing process, so parse tokens instead, please. And then, okay, we're going through this. So, and tokens are line-based, right? So this is a single line. So what if we have a failure, right? Because I return false here, even though there is no return type at the moment. But let's just think through this. So if in that line I have an unknown symbol, so we look it up, can't be found, we print out the error message, what are we doing? Do we need to do anything else in main? No, we just want to pass the next line, right? And we look up the last token we found anyways, which will be either an end of file or a new line. Like, that is guaranteed from however we structured this. So yeah, this doesn't need to have a return type. So we just print the error and return. Okay. So then TBA process operation. Does that need to return an error? Because we're validating the end of the line? I mean, not really, because we print in place, right? So really what we want to do is we just want to return no matter what. So it only skips white space. And then whatever token we're getting, we're just returning. Fine. And then down here, we can just do that. So if there's something wrong, then we go out of here, in which case we land on here. And what do we do after an operation? Well, we know we don't expect anything, so we just return. And now we can change this error message as well, because, so this is an operation, but here we can say GBA print symbol error. Exactly the same thing, but we can say invalid operation. Because we're expecting an operation, every line needs to have an operation, right? So symbol name and symbol length. And line would be context line. just return. So this just should be void as well. And we actually don't want to name this process operation. We're saying it's parse operation because it is the parsing process after all. There we go. And then validate end of line. How about parse end of line? There we go. Okay, and now we can put this into a header as well. What am I looking at? New item, GBA header.h. No. Brain fart. GBA parse.h. Cool. So parse tokens, parse operation, parse end of line are now living in here. Sweet. And now I just need to resolve all these issues here. Context should probably live somewhere else as well, so let's do that. GBA context.h. Context, and we want the context struct in there. That essentially needs to include the whole world, right? Import project. So we have a GPA buffer that we need there. We have the GBA token that we need there. And we have GBA symbols that we need. What is token buffer size? Right. That is defined in here, so let's do it like this. Anything else? Eventually we can like extract all of these like allocating buffers and stuff and put that in like a context init method. But for now, let's just not bother with that. So this will be include GBA context. Sweet. And then here in parse, include projects. I'm gonna add GBA context. Okay, import CRT. So the C runtime, and we need stdio.h. And that's it. Oh, an error, right, because we're printing out errors, of course. So include GBA error. Right, Let's see what we fucked up. Rebuild all failed. Oh, right. Include GBA. Hang on. Parse, right? Yes, there we go. The whole header structure is a bit messy, maybe. But you know what? It is what it is for now. Kind of try to separate things logically a little bit, and then we have just one C file where we just dump everything in, so that should be fine. Okay, oh, cool. So we already have that working. So RLCA, RLA, and that should have unexpected thingamajig here, right? Let's also test, so if we have one of these, let's test if we just have a separator here. Then let's have a valid command, but with a separator, and then actually have a valid command with a bunch of separator and another one of these, but with a big white space in between. So in this instance, it will only report the first separator as an issue, not everything else, which is fine. I mean, let's see. So this file would result in these error messages, right? So we have unknown symbol. Oh, interesting. The separator is valid. Why is that valid? That should not be valid. Because we don't check for it. Okay, GBA token type separator. Apparently I've been typing, but not typing. Interesting. Whatever that was. Weird. Okay, whatever. Whatever. Okay, we have this. So what do we want to report here? What did I do for the new line? Unexpected separator. Yeah, let's just report the same thing. Okay. Fix the bug in the meantime. So this file will result in these error messages, right? Unexpected separator, comma, in line 2. Then we have unknown symbol, in line 3. We have RLCA, which will work, but then we have unexpected symbol RLA in line 4. Unexpected separator, comma, in line 5, and then as well unexpected separator, comma, in line 6. So if we have multiple lol like this, they wouldn't be reported, right? And now I'm wondering whether that should be, like whether that is enough, or if I should refactor this a little bit so it reports every single symbol that is wrong. Okay, I want to change the arrow structure a little bit. I want to say this clearly like error, and then the line the error is at, and then the error message, not the line in the last thing. So, for example, here it would be error line percent %LLU. Maximum amount of tokens reached. And then we have here context line. Okay, and we just copy this structure here, this format, and use it for the other error messages as well. So GBA error, except Windows errors, those are kind of special, right? They have nothing to do with the source line, but like symbol error, for example, is. So error line LLU. So we do this, and we have error type unknown symbol, but line needs to be first one now. So this. Right, so if we call this, then we should have this here, unexpected separator, comma. And then here as well. Okay, that looks a bit nicer. So one way to print multiple errors would be here. So in parse end of line, instead of returning, we're just gonna continue, right? Let's see what that would look like. Right, so we report every single thing. Is that better? What do we think? Any comments? Would you rather see every single thing that could potentially be wrong, or just the first thing in the line and then figure it out as you go along? Because it feels like it's a bit redundant right now here, right? It spits out, well, there's a comma wrong, a comma wrong, a comma wrong, but it doesn't say which exactly which comma, right? I mean, okay. I have an idea. Brace yourselves. Instead of just saying unexpected separator, let's tell them what we actually expected, right? Expected end of line. Expected end of line instead. Ah, shit. I would have to change this now as well. No, this is getting stupid. Okay, where do I call print symbol error? I call it here. And then just here. I mean, unknown symbol. What I'm gonna say, expected known symbol instead, right? Doesn't make sense. Unknown symbol is perfectly fine. And then here, print symbol error in invalid operation. I mean, I wouldn't want to print out every single operation that's valid, right? I mean, in terms of the Game Boy, that's not that big of a deal because it's like, what, how many did we say? 50 different operations or something, right? Yeah, no, I don't want to print them out. That will be too much. If you have like a whole bunch of lines where you have the wrong symbols and then you just spit out all of this, that might be insane. So it's just this where we have an expected message. So can I do something with these format arguments? You know what? If I think about this too long, with print unexpected symbol at end of line error. we go. Then we also don't need the arrow type anymore. And then we're just gonna say unexpected symbol expected end of line. If in doubt, just make a new function. Whatever. I said expected end of line instead, so let's do that. And GBA print symbol error is still valid here because we have one unknown symbol and the other thing would be an invalid operation specifically. Okay, cool. So unexpected separator, comma, right? We can say expected operation instead. Unknown symbol, ha 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 ha. Yeah, that is fine. Unexpected symbol RLA, expected end of line instead. Okay, are these all actually the correct errors? Expected operation instead. Yeah, okay, cool. Unknown symbol, ha ha ha. Well, we don't know what we expected. It's just an unknown symbol. RLCA. Unexpected symbol RLA, expected end of line instead. Yep. So we know all of this needs to go. Unexpected separator, expected end of line. Yep. And then again with all the spaces. Yeah, that's just fine. I think I'll leave it like this. This seems okay. And spaces in the beginning are valid as well, right? Just making sure. Yes. Okay. Okay, cool. That isn't so bad. Now, how long have we been going? 1 hour. So I can still go a little bit. My voice is feeling rough since yesterday. I think I'm not used to talking that much as I did yesterday. That was something else. But I'm gonna power through. Stay strong. Right. Operations. So we have the instruction here. I know it's called instructions, right? But I kind of like to name this operation because LD is an operation, inc for increment is an operation, right? And then all the arguments are operands for that particular operation. And that whole statement will then generate the instruction, right? So that's my terminology that I'm using for these things. Whether that is what's accepted or not, I do not know. So as you can see, I have sorted all these. Oh, I was looking in the manual for the hex code. I could have just looked in here. Jeez. Oh man, I could have made it so much easier yesterday. Oh dear lord. Um, Actually, let me copy this file. Chip, chip. And let's have a look at the copy. So we implemented no-op. Let's start to sort these a little bit based on the arguments that they take, right? So we have two arguments. Here we have one with one argument, right? This one as well. This one is two arguments. This is no arguments, so we implemented that one. This is definitely two arguments, two. Okay, here we have actually a bunch of them with just one argument. Two arguments. Right, okay, that was the mode for usually considered one instruction because stop is followed by a no-op. Okay, what's this? So this is 2, 2, 1, 1, 1. Okay, those go up here. That is just one. Sorry, no. Right, jump relative. There we go. 2, 2. This is okay. It's okay if I just copy paste it, I think. This is 1, 1, 1. This is none. I should have sorted these based on the operation name in retrospect. Oh shoot. Got to copy the code. Okay. And CPL. Ink, ink, ink. Well, ink and deck, I guess. There's one, that's only one. Then we have this chunk right here. Sorry, I know that is probably looking very tedious, but just something we have to do. Okay, so these are all load instructions. Jeez, there is... You see, I wasn't kidding when I said load is the most complex one there is with all the different operands that you can select there. Okay, we have halt, which is no arguments. And yeah. Okay, yeah. Then we have add t. Okay. And okay, or XOR, fantastic. That is a bunch of them. Return and pop. Chop. push. Okay, so push RST. Wait, right, red was one of those things where it could have a return or not. That was one of the annoying ones. Okay. Right, so these. Okay. Here are ST, red, and red eye. Cool. And red eye should really be up here. Just do it this way, otherwise I'm going crazy here. Yeah, there's a jump instruction down here that we need to take with us. RST5. Okay, fine. Okay, what do we have? Pop AF. Missed that one. Push AF or RST. And then this one down here. And I saw a few ones without arguments down here, so there was DI and EI. Wrong. That's wrong. They belong up here. Okay, in case you're wondering, these with those lines here, those are instructions that are invalid to the CPU. So this doesn't mean anything to it. Well, so it doesn't mean anything in the terms of the manual, right? But it could be that if you're using one of these, the CPU might actually do something. We just don't know what. I'm not sure if anyone has ever looked into it, but you might have heard that, like, for x86 CPUs, sometimes if you have like unknown instruction codes, that they actually might do something. It's kind of hard to figure out what they're doing, and there's some people trying to play around with these sort of things, but suffice to say, we're just not going to use them. So, okay, I saw an XOR here that I forgot. Oh, and an AND. call. Shh. Why are you doing this to me? Oh, man. It's easy to get lost in these things. Okay. So, and there's also this one, which is a whole subset of instructions. So if you encounter, if the CPU encounters CB, it will look into the next byte, which is this subtable right here, and if it's one of these, it will be one of these instructions right here. And as you can see, well, most of them only have, well, not most of them, no, that would be a lie. Some of them have only one argument that they take, so technically those belong into the list up there as well. But I can look into that later on. So let's just see if we have all of these, just to make sure again. I know I looked into the manual, but it was quite late yesterday when I did this, so I'm not sure if I did the correct thing or not. So let's go to parse right here. And let's see. We have RLCA, which is 07, correct. We have RLA, which is 17, correct. We have RRCA, which will be written as 0F, correct. We have RRA, which will be written as 1F, correct. Let's go further down. We have red eye, which is written as D9, correct. DAA, which is written as 27. CPL is 2F. Then we have NOP, which is 00. Then we have CCF, which is 3F. SCF, which is 37. DI, which is F3. EI, which is FB. Halt 76, and then we have stop, which is 10 followed by a no up, which is 00. Correct. Now we have return right here. Reason for that is it's has a bunch of optional arguments that can be used, right? So return is something a bit special. So you can have optional arguments, right? So we should probably get them all together. Do I have them all? Okay. I accidentally took Retty with me. Okay, so these can have optional arguments. So I won't worry about these for now, because those are a class of instructions that kind of need to be careful anyways that the jump instructions, which in the assembler itself should always work with labels. And I explain why once we get to them and we implement them and what they actually mean. So yeah, so jump relative so we have ink, deck, there's another ink, deck, there's another ink. Okay, 2 inks right here. A few more inks. I think that's all the increments. Yeah. Okay, then we have all the decrements. Then we have all the ends. Oops. X or CP pop push RST. Right, there's different pop ones, yeah. Push. Whoops. Right, there's another jump instruction. This is pop. Call and jump. Yeah. So these need labels. So I'm probably not going to get to them today. Okay, so these are done. This we will deal later with. These need labels, so we will also deal with them later. So we're probably going to do a whole bunch of these. We have CP. Oops, where is it here? And XOR. Okay, cool. Just trying to see what the easiest to start with would be, and I think that would be RST actually, because RST just as the first argument just takes an index from 0 to 7. So that should be easy to do. There is a bunch of other ones that take an index later on, mainly here in the subset instructions. As you can see, bit, so bit 0, bit 1, 3, 4, 5, 6, 7, the same of RES. So we can already have a method here that would be something like void GBA parse index, right? Because we're expecting an index. So GBA context T. Okay, what did I say was it? RST, right? Yeah. Okay, let's go to RST, which is right here. So what do we need to do? Well, for one, we need to increment the current token index, right? Because we processed that one token, but we want to go into the next one. So token, no, this would be in context, token index plus plus. And then we would call GBA parse index, because we're expecting an index argument, which definitely needs to be there, and just pass in our current context. Once we're done, we're parsing the index, and then we come down here where we advance to the next token after that index and make sure it was the last argument right there. Okay. That's not too bad, is it? So let's go to parse index. How does that look? Well, we have a for loop where we go to context token index is smaller than token count. Context token index plus plus. Well, actually, no. It's far simpler than that, right? So we advance the token index. I'm wondering whether I should just... Yeah, you know what? Let's just have that in there, shall we? So we're doing this. What are we expecting immediately after an operation? Well, we need white space. We need white space before we go to the index. We don't want the separator or anything like that. We just want the white space. So if context tokens context token index type is not GBA token type white space, right? So we print an error message if we do not have a white space, because we expected a white space, none was there. So, what if this is a... So if this is a separator, right, this will fail. If type is new line, it will fail. If it is a comment, it would fail. And yeah, it basically means there's nothing there, right? Because the line would end in that moment. Hey, Eurus Cyber. What is a Game Boy assembler? Is it like an emulator? No. So, an assembler is essentially a program where you can write assembly code to basically write a Game Boy game, a ROM, right? So imagine it like this. You have like a little program like this with specific instructions that happen. You put it through an assembler who then spits out a Game Boy ROM that you can load in an emulator and start running, right? Essentially, if you want to look up on Wikipedia the assembly programming language, it's like a very low level programming language, very close to the CPU, because you're literally coding in CPU instructions. So you're typing stuff out that the CPU would understand, basically. I mean, there's already assemblers out there, right? Or even some... it is madness. Writing assembly is madness. But it's also fun because you kind of learn what the CPU is doing, you know, under the hood. So essentially, even Python code, right? At some point, all that you're writing in Python is translated to a machine language that the CPU understands, right? So sort of assembler or assembly. Not quite, but very similar to that. So we're quite a few levels deep down. And even though there are assemblers out there, oh, thanks for the follow. Even though there are assemblers already out there, I just want to learn how to write tools like that because I've never done that. And I was always curious, like how are programming languages written, even like compilers, assemblers, all this kind of stuff. So that's what I'm doing here. Okay, so if the next token would be a new line, sorry, I have to figure out where I left off with my thoughts. Then we still go down here. But we do not want to increment the token index if this one fails. We strictly just want to return immediately. So what we probably want to do is have a bool here. Say return false. And if this fails, we return. Otherwise, if this doesn't fail and we actually read out the argument of that specific operation, then we want to make sure it is the last thing in the line, so we actually want to go down here to GBA parse end of line. And thinking about this, we can probably advance the token here. If we're already doing it in here as well. Okay, so we're checking for white space. Now, the next thing we want is, well, we want a symbol. But we want a specific kind of symbol, right? I see myself being stuck with the temporary name right here. um, so the problem I'm having right now, where's the tokenizer? So here, get tokens from line. I think we want to advance that to alphanumerics as well. So symbols cannot start with a number, which is fine. So what we want to add is GBA token type number. Yes, and we do not want numbers here. I mean, the learning curve for assembly code is steep. Well, I'm not sure. So I'm not well versed in assembly, right? I've yet to write a GameBoy game. But looking through the GameBoy programming manual that I have right here, it's just very different if you're used to programming languages. Let's put it this way. Is it steep? I mean, you want one? So the thing is, so these programming manuals here, this one has been released in 1999. And it says right here, confidential on it. So, but if you know, there's little websites like Google and things like that, and if you actually look for it, I bet you find a PDF somewhere of it. Because that's more or less what this is, just a PDF in a nice book, printed out and bound as a book. But if you do not want to get through the trouble, there's also this website right here, which is called gbdev.io. And it essentially is the same as the GameBoy programming manual, where it lists all the different you know, instructions and all kind of stuff, and how the Game Boy CPU works and how you need to talk to it. So for example here, CPU instruction set, here we have all the instructions and what they do. Yeah. They also have a assembler tutorial if you want to go through that with a Hello World application. So for example here, let me put it on this side. So this is, for example, just a Hello World assembly code. And then you could assemble this one with an assembler, and then take the ROM output and just put it in an emulator and run it. Or even on the original hardware, if you have that. Of course, you need a cartridge that allows you to put in SD cards and stuff like that, but yeah. Yeah, exactly. That's how people do custom ROMs. That's essentially it. Okay, so where was I? Right, so here, when we're trying to get the tokens for the line, we look into the buffer, we find all these specific characters right here. And if it's none of these special characters that we recognize, then we go into this default thing where we say, okay, this is just a symbol. But let's extend this a little bit. Because if is num, or is it is digit? Is digit, yeah. So there's this is digit function right here. That jumped to the completely wrong line. Okay, what? Why did you do that? Is digit. Whoops, not us digit, is digit. What? Huh? So it jumped to definition and it jumps to this. But this is not what? Whatever. Let's not worry. So let's get the current character like this, and then switch over character. This way we can reuse it and don't need to index later on into this. So, and we're just checking, is the character that we fetched, is it in the ASCII range of a digit, right? So is it actually an ASCII digit? If it is, we assume that the next symbol is a number, right? And we can still call find next token character, because now we just assume everything we're reading is a number, even if we have something like, hang on, this might be behind my portrait, I need to watch out for that. So even if it might be something like, I don't know, 3, 4, 5, A, B, C, well, that's is a hex number, right? But for example, we're still trying to read that as a number, and then later on in the parsing stage, we will just try to make sense out of this number and realize, well, that's some rubbish. We don't know what this is, so in here we're just trying to approximate for the tokens. All right, this could be a number. Otherwise, it's a symbol. Okay, so now we need to adjust all our parsing codes. So, because now we actually added another thing that could go wrong. So what if we're parsing a new line and we suddenly encounter a number where we don't expect one? Well, we need to print out an error for that. Unexpected, I guess, number. And I realize if I want to print out the number in the error, I need something similar to this with a symbol. Where we convert UTF-8 to 16 so we can print it out properly. We can just use print symbol error, to be honest. That should work. Print symbol error. Unexpected number. Yeah, I'm not too happy with how I did the whole error handling and stuff, so I probably need to rework this in the future, but for now let's just leave it as is. Whatever, it is what it is. So we have this one right here, so we have the symbol name. The current token is like so. So we have the GBA token T. Let's just fetch the current token out. Why not? GBA token T. Current token. It is the address of this one. And then we have current token type. Well, just call this number. Number length. We have number and number length. And line is context line. There we go. Okay. Unexpected number. We also need to account for unexpected number in parse end of line, right? So if we have a GBA token type number, I mean, printing this out, this unexpected symbol, is probably not a bad idea, to be honest. Um, yeah, I need to rework those errors. Let's make it to do, because, like, I really need to. We've done that. Done that. And this is what we're working on right now, so let's just. Okay, rework how error bending works. Yeah. It's probably easier to, like, clean that all that up later on. Once we have the whole parser working, you kind of recognize some more common patterns, and then can go from there. Okay. Cool, so now we can deal with numbers. Let's just do false as well for now. Let's test this out. So this is our program. Still works. Fantastic. So now if we have a few numbers in the beginning of the line, that will throw an error. If we have here, that will throw an error. Except for, well, that won't quite work yet, right? But RST, and then a number with like some text, or a negative number, which we don't support yet. Otherwise, 0, 1, 2, 3, 4, 5, 6, and 7. So these are valid cases. Everything else should be invalid. Let's say or minus. Okay. So, whoops. Let's do it this way. Okay, so unexpected number 0, yeah, okay, because we assume it's a number. Unexpected symbol minus, blah, 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 because our number parsing doesn't accept minus signs yet, negative signs. I mean, eventually I will change that. Unexpected number, yep, because we don't expect a number there. And then RLCA, we also do not expect a number that. We expect an end of line instead. Now, RST doesn't throw any error messages yet because we have not done implementing it yet. Yeah, error handling is not easy, right? It's a craft on its own to actually also provide good error messages and everything like that. But I mean, it is what it is. Oh, really? You're actually using ChatGPT? I think you might be the first one that I actually interacted it that is using it for programming. Not saying it's a bad thing or anything. It's just in my immediate surroundings, like circle of friends, I don't know of anyone that's using ChatGPT. Um, and I myself haven't used it because, frankly, I don't know. I just like programming. I just like thinking about things on my own and just like trying to come up with a solution. And if you follow the stream for a while, you notice I usually also don't care what other people think of the code that I write and like how it's structured. I just do my own thing and just try and get it done. So we'll see. Okay, parse index. Let's continue with that. So if we have a white space, oh no, if you don't have a white space, how can that happen? Well, if we have RST and then immediately a comment, right, that would be an error. RST and just a new line after it, that would be an error. RST at the end of the line, also an error, because there's no new line character right here, but that will be end of line instead. So actually, let's print something out real quick, but I will definitely have to adjust those error messages. So F put WS, right? Yeah. Error expected white space, whatever. This goes to std error. And if we have found, oh, right, I need to be careful here because I also need to check if context token index is smaller than context token count. So if this is the case, then we just do f put ws. I don't think that can actually happen, to be honest, the way the code is structured right now. But let's just keep it in. Okay, then we need to, so we found a white space. We need to increment the token index again. Nice. Try and ask it to write an assembler for GameBoy code, for GameBoy assembly. I'm curious what it spits out then. So this definitely can happen, though. No, can it? No, it can't. Maybe I shouldn't worry about these increments. Just, whatever. Let's YOLO it. right? This will just clutter everything with error messages, and I think the way the tokenizer works, that can't happen anyways. So let's not worry. Later on, we can maybe come up with some macros to like do this properly and have error handling in there, but I definitely don't want to type it out the whole time now. So at least not now. We can actually just make this a to-do for later on. Make this thing robust, right? That means once the whole parsing code is done, going through it, and just reason about the code. Right, okay. So it just explained to you that you need to use other assemblers to assemble a code. So the actual ROM. You don't need to post the assembly code, don't worry. I was just curious. Okay, what we're expecting here is a token type number, right? Token type number. If we do not have a number, something is wrong. So expect a number, something else was here. Right. And then once we have the number, I'm so tempted to make this now a function that just says get next token. I should probably do that. Let's quickly add one. Where would that be? Oh dear, oh dear. Well, it's kind of in a context, right? So, okay. Bool, TBA, get next token from the TBA context T. And what we're spitting out is GBA token T, pointer to that token. Right, so if context token index +1 is still smaller than context token count, then increment it and fetch me the token, which will be this. Tokens token index. Actually, we can do it this way. And then return true. Otherwise, token is null, and we return equals. Cool. So, well, this is just the assembler, right? So I cannot run it anywhere. This is just the assembler that allows me then to compile my assembly codes that I can use for the Game Boy. Uh, Eventually, I do want to write something for the Game Boy once this tool is finished. And then, well, I will run it on the original hardware. I'm still waiting for my EverDrive though, so I can use an SD card on this thing. But alternatively, I also have the Analog Pocket right here, which is an FPGA emulation of the Game Boy, and it has an SD card slot where you can run your own ROMs, essentially. But I also would like to write a Game Boy emulator, to be honest, because that sounds like a lot of fun. But to the task at hand, we need to finish this first, right? So now this becomes a bit nicer. We can say GBA token T, a pointer to the token, which is fine like this. And then we can say if not GBA get next token from context with token. Wait, no. How do you see, right? Does that work? I wonder. I don't think this will work. Yeah. Because I need pointer of a pointer. Because we want to set that pointer to whatever this is pointing to. Otherwise it's null. So this can be uninitialized, but we need to return the address to that. There we go, that should do it. Yes. Cool. So if this doesn't happen, or this happens, then token type is not white space. So now we kind of combined these statements together, but we will also get a failure if we suddenly start incrementing the index outside of the actual token range. So I do have to have two different ifs in there. This is kind of nicer. Whoops, my alarm. Okay, I have about 40 minutes left. For today at least. Okay, and then we can do the same thing down here. But it's gonna be token type number instead. Okay. What? Forgot the new lines. Fantastic. But I also kind of want to know which line this happens, right? So, okay, let's just do this. Expected white space, line. Fine, I'll do the right error messages immediately. Jeez. Okay. There we go. Same format. This would be context line. Expected number operand, but no. Number operand is missing. Okay. And then we can do the same here. I mean, it's the same error message right now, but whatever. Okay, so what is going on? Line 22. Number operand is missing, which is true. Line 23, number operand is missing, which is also true. Line 24, number operand is missing. Nope, it is right there. It is right there. Why you lying? Okay. Let's see what I just screw up. Wait, what? We do not even get here? Wait, what? Token type symbol. Okay, fair. Token type symbol, okay. Token type symbol. Why are they all symbols? Oh, because I'm dumb. Yeah. Context token index plus plus. I do not like the prefix operator. I could do that, but that kind of looks freaking weird. Let's just do that. Or alternatively, we can do that, say that, and then That way you can just leave it in the register. Fine. Yay! Okay, cool. So now we have a number. Now we can start parsing the number. Oof. Well, that was something. So index. We know that the index just goes from 0 to 7. There's nothing else, right? So there's one simple check we can do immediately, which is token start, no, token end minus token start is bigger than 1. If that's the case, this is a freaking invalid index, right? Invalid number expected 0 to 7. Cool. Let's see that happening. Where's the output? There we go. And we already have that on line 24. This is way too big, so it says invalid number. Same for this one, which has ha 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 included into it, but we don't care, right? Number 26 says number operand is missing, again because we do not recognize a minus sign as numbers yet, but we will in future. And then let's remove the breakpoint. I'll let this finish. So line 26, yeah, so these suddenly all work. And then the last one, yeah, line 36, there we go, number operand is missing because there's no number. Okay, but now, what if we have 8 and 9, right? So these things also need to fail. So for that, we just look at the token byte, token, and how are these instructions actually encoded? Ah, okay, this is cool. So these three bytes right here, I'm not sure if you can see that, but here, these 3 bytes here encode the index, right? So this is binary 0, 1, 2, 3, 4, 5, 6, and 7 right here. Okay, cool. So we just need to check if token, no, this won't be in token, this will be in the context, in the input buffer, in the data, and there we need the token start position. End position is 1 after that. So we can just fetch this number. Right? And then we can say if number is bigger than, well, 7. Oh, hang on. This will be ASCII, right? Okay. To the ASCII table. Sure. So this will be hex 30 to hex 39. So what we want to do is subtract 30. And then we can check if it is bigger than 7, and if it is, we're just going to say invalid index percentage %d. That would be number. Okay, and now all that is left is writing our instruction into the output buffer, so it will appear in the ROM, and we follow this encoding. Now, so what we want is, whoops, sorry about that, calculator, look at the bits. And we have this pattern of 3 here and here. So this is hex C7. This will be our, our base number, essentially. So we can say U8 operand, no, instruction. The instruction is 0xC7. And now we just need to shift, no, we need to or in our number shifted over by 3 bits and write that to the output. So did you get a degree in CS? No, I did not. So I attended university, however, but I never finished. Reason for that being is because, one, university wasn't my cup of tea, and a friend of mine at the time opened a video game company, and I was eager to join. So, yeah. The company then folded, so it kind of never materialized, so I wasn't there for long, just for a year. No product was ever released, which was sad. But I still got jobs after that, and now I've been 10 years in the industry, working as a software engineer in various companies, mostly in the financial sector. So you don't necessarily need a CS degree to work if you can show that you have the necessary skills that they're looking for. That's the important bit, right? So make sure you have, I don't know, a portfolio, some projects that you can showcase, if people ask that. There's also lots of tests that you need to do in interviews these days for companies, right? So like some coding sessions or stuff like that. I mean, I learned a lot of stuff by myself, really, by just hacking around and trying out certain things. And so far, I've been very lucky to still get jobs, so I don't know. But I think with a degree, it's definitely easier. Yeah, I mean, it just works for some people and some it doesn't, right? I also switched universities in between, so I was in 2 different ones and just... Actually, I switched 3 times if you think about it, because I also switched the course in one university to a different one. It was just... it just wasn't for me. Sometimes I regret it, but whatever. It is what it is, right? Can't change the past. Okay, so we have the instruction. Let's write this to the output. Yeah, life can be messy. Okay, so the output would be in context. We have our output buffer right here. Let's just use data. We have the output offset, which we need to increment by 1 once we have written the instruction. And as you can see, even though we have, you know, let's make this a bit smaller again. It's huge text. Even though we have one operation and one operand, the resulting instruction is still only 1 byte, right? So I went through the whole thing with the calculator to figure out C7, but I have it right here. I should read my own freaking text documents. Jesus. Okay. Stream blindness, I suppose. So yeah, we just need to write 1 byte into the output, and that byte will be this instruction. And then we can say return true. Fantastic, there you go. We have parsed an index. Isn't that fantastic? Except we should probably not write the index in this method. And I tell you the reason why, because this is now just for this one instruction right here. But there is a bunch down here that also take an index, but obviously have a completely different makeup, right? Although I believe the index is still in the middle part. It seems to be, yes. But I think what we should do is do a pointer as the output, where we get the index. Right, so what we would do instead is say index is number. And then down here, we're gonna give U8 index, and we're passing the address of that index. And once we've got it, we can make an instruction out of it and write it into the output. Actually, we can just do it like this in one neat line. And to make this even, no, because we do not want to go into parse end of line, so this is okay. Cool. Now we need to test. Let's do that real quick. Come on, come on. Scroll up, uppity up. Okay. Right. So we had line 36 to 38, which should fail. And indeed 36, invalid index 8, expected index of 0 to 7, and invalid index 9. Excellent. So this works. Now we should check the output. Okay, let's get rid of all the other instructions, so we're actually not clouding what we're doing right here. Um, let's comment this out because this is a case we want to test later on. Okay, run this again. Cool. And then we have our output. So it goes from 0 to 7. I want this and this, right? So let's see. We have a C7, correct. CF, correct. D7, correct. DF, correct. E7, correct. EF, correct. F7, correct. And an FF. Nice. We can successfully use RST in our assembler. So let's move this into done. To do. Let's keep this like this. And probably done. Should be somewhere down here. All the way down, all the way down. Yeah, as you can see, we still have loads to go. Right. But the good thing is, once we're like getting all these bases done, for example, like parsing the index here, we can now just reuse the function that we've already written for all of these later on, right? So now we just need to do all of, like, for these, whatever these are, right? So we're just building our building blocks to then get to the massive, massive LD instruction, which is just insane. And also the more trickier jump instructions later on. I do like how you vocalize what you're doing. It's nice knowing the logic behind stuff. Oh, thank you very much. Yeah, I try. I mean, it's no use if I'm just, you know, sitting in front of a camera and type and don't say anything, right? I want people to be able to follow and get like a reasoning of like an idea of why I'm doing things the way I'm doing them. It doesn't work all the time. Sometimes if I'm like deep into debugging or like trying to figure something out on how to do something, I tend to get quiet as well. But I mean, I'm used to streaming, so I'm trying to learn all of that. I mean, I suppose this is the first time you're watching the stream. In my previous streams, I've also like once in a while whipped out the iPad to like do some drawings and explain certain things on how things work. For example, how CPU reads data and executes instructions and things like that. Actually, that's a good point. Let me drop you a link here. I do upload all my recordings onto this YouTube channel from previous streams. So if you want to follow along, okay. I guess this is how you pin messages. First time I'm doing this. So you can go back a few recordings of like, well, I haven't uploaded the stuff where I started the assembler yet. I'm quite far behind with editing all those videos and uploading them. But the previous project was in there, which is the GB header extractor that I wrote on stream. That's basically just a little tool to go through all your ROM files that you have on disk, all your Game Boy ROMs, and extract information of the header out of it and put it in an XL file, which you then can open with any editor whatsoever. And basically, there's some interesting information in there because it shows you like the game title, the publisher, all this kind of stuff. Oh, thank you. uh, it does feel really good when you get something working, yes. And the reason why I like low level stuff like this, and especially also why I like working with C, is because, you're not getting distracted by all the fluff that other people tell you are important for you. I know this might sound weird, but for example, let's take a programming language like C sharp, right? You have all these different libraries and patterns and classes that you need to you have a specific way of how to do things, and suddenly you're like being so abstracted away from the problem that you're trying to solve that you're like starting to think in terms of like, oh, what do I need to do to make this programming language work, right? How do I become a coder for this language when this is not what I want to do? I work in a way of like, okay, how do I can get to my goal as quickly as possible with as little um, hindrances in my way, I guess. I don't know. For example, I don't like when people start talking about like syntax or arguing about programming syntax, right? Oh, you should have used this operator there, or this class there, or you should have written it like this. You should have used an interface. And it's just like, well, I don't care. I just want my program to work, right? And it took me 10 years with C Sharp to realize that. Yeah, basically. Oh, that was interesting. Your message got held for moderation because of shut the foo. STFU. Interesting. I mean, to me it is PC, so it's fine. Okay, well, so we're approaching the 3 hour mark, and I'm not sure I want to continue much longer because that will wreck my voice again. Oh, and my alarm is going off again. So let's see. Can I do something quickly for like 10, 15 minutes? What can we do? 10, 15 minutes. Uh, you know what? Let's do registers. So A, B, C, D, E, H, and L are registers. I would love to explain what registers are, but that definitely will go over the 10-minute mark. I will probably explain registers more when I'm actually trying to code a game for the Game Boy, just to explain what they are and how they work. Because then we have to look at all these operations or instructions rather separately, anyways. Yeah, let's just do registers. Okay. So registers are just. Okay, keyboard is on the wrong PC. Hang on. There we go. Registers are essentially, as you can see, symbols, right? So it's just some letters, C, D, E, H, L, L. We have B, C, we have B, S, P, all this kind of stuff. These right here, N, Z, Z, N, C, and C, those are not registers. Those are conditions specifically for this stuff. And I will probably do something else for these anyways, but I'm jumping ahead here. So let's just do registers. So what kind of registers do we have? Well, instead of just looking through this whole text document and trying to figure it out, I can just look in the Game Boy manual real quick because they have like a list of them. So it's A, B, C, D, E, H, L. Those are the basic ones. A, B, C, D, E, H, L, yes. And then there is register pairs where you can combine those. A, B, C, D, E, H, L, yeah. Okay. So how would we recognize registers? Well, we have our little symbol, our hash map for symbols, where we already have all of these symbols defined. So we can just add them in there as well. So we probably have another symbol type. Let's say GBA symbol type registers. Register. Yeah, register. Right. And then we probably need a similar enum to this, where we specify the register type. Type div enum GBA register type enum. GBA register. Did I just? No, I typed it out. Okay, so register type T. And then, which ones do we have? Well, we have A, B, C, D, E, H, and L. Now there is register pairs. Let me go to the page in the manual so I don't screw it up. Right. So there is, we can combine B and C together as one register. We can combine D and E together into one register. We can combine H and L into one register. And then there's a special one called A and F, which is the register A and flags for the CPU. Flags you cannot address separately like this. And then we have SB for the stack pointer. Now, do we have program counter? I would assume that would be a thing, but maybe not for this CPU. I apologize if I might be throwing some terms around here that I haven't explained before. I will get to it, but probably on the next stream. Not now. Just take your word for it. I'll promise on the next stream in the beginning I will probably start explaining what registers are. I shouldn't make promises like that. We'll see. So, do I stream often? Yeah, so far I try to stream every day. Just because I have a lot of downtime on my hands at the moment, so... but it's usually just for like 3 hours or so, and not always the same time frame as well. Sometimes it's in the morning, sometimes evenings. Depends. I do not have a fixed schedule, I should say. So we can have an operation type, but then we have a register type. So it could also be a register, right? Okay, and here we run into the issue that register is a keyword in C. So we cannot name this register. Shoot. And you cannot override keywords like in C#, right? So, registers? But that's kind of wrong. Okay, fine. Let's just call it registers. That's annoying, right? Well, I could capitalize it, but I have not capitalized anything else in the code base, so that's a bit annoying. Let's just call it reg. Then I should name this to OP, but actually, yeah, let's just do that. There we go. Okay, so that is the symbol type. I have the symbol table. Okay. We have insert symbol, which is fine. Insert symbol by name. Yep, we have that. Okay. So these are operation symbols, and now we need to do the same thing with registers, because we need to pre-register them before the program starts, so they are in our hash map. So GBA register symbol info T. Wait, what is register symbol info T? Oh, it's this. Right. Register symbol info. And then we have register type with a name and an alternative name, which is just uppercase, lowercase, because you could type both. So you could type A, or you know, for commands like LD, you could write LD or LD, doesn't matter. But they have different hash codes for the symbol table, so we need to like add them separately. Okay. Right, we have this one. Register symbols. Okay. Cool. And then we can say A. Whoops. oops, come on, A, and GBA register type A. B, C, D, E, H, L, B, C, D, E, H, L, A, F, S, P. Okay. Not F. H, L, B, C, D, E, H, L, A, F, S, P. And the same in lowercase. And the same here. B, C, D, E, H, L, B, C, D, E, H, L, A, F, S, P. Cool, so we have the const now, and now we just need to add that into our hash map. This is now OP. And fine, I guess. Just make a separate function, why not? Add register symbols. And we have the register symbols and register symbol info. This is how we get the size of the array. So get size of the array in bytes and divide it by the size of the struct, so we can get the number of elements. Then we iterate over the number of elements. Whoops. So we get reg info out of GBA register symbols I, sorry. This will be the register. What? Would be helpful if I know how to spell stuff. And then we add the symbols right here with the attached sim info. Okay. And now we just go to the same call site as this. And this. Okay, so now we're adding the operations, the known operations to our hash table. We're adding the known register symbols to our hash table. And then in parse tokens, where we look up the symbol here, operation is now OP. Right. We could instead have a case GBA symbol type register. And this is only temporary now. Because otherwise we get an invalid operation. I just want to make sure that the code works as is. So we have the symbol, we have the info, and the info would be so reg is the register type, right? So let's make a little switch in here. Whoops. And then we have all these cases of the registers that we just added. Where are you? There we are. Let's go to the enum right here. Then use my little trusty Sublime Text. Because now we can do multi-line editing. So case this. What do we want to write out? Let's just do put WS, and we're writing out register. Fine. Yeah, that's fine. Okay, great. Cool. So copy this. Bam. So A, B, C, D, E, H, L, B, C, D, E, H, L, F, and S, P. Okay, so now we are recognizing all these registers. So if I should just put them in here, we should see the outputs. So we can say, thanks, autocomplete, not what I wanted. A, B, C, D, E, F. Nope, always. Oh, god damn it, autocomplete. H, L, B, C, D, E, H, L, A, F, S, P. And the same in, wait, is SP also an instruction? I sure hope not. No. Well, this must be for some... whatever. Okay, so, and then now we probably want to test lowercase as well, so A, B, C, and now autocomplete is gonna fuck me over all the time. D, E, H, L, B, C, D, H, L, A, F, and S, P. Okay. And we have compile errors. Why do we have compile errors? Really? Okay, let's not worry about that warning. Put WS undefined. Is it wide? No. Oh my god, I hate this. I hate this so much. These names. Nope. Look at that. How is this intuitive? How? It's underscore suddenly. Like you follow one pattern and then you say like, fuck this pattern. I'm making up my own rules now. Okay. Whoops. Cool. There we go. So register A, B, C, D, E, H, L. Cool. B, C, D, E, H, L, A, F, S, P. Cool. A, B, C, D, E, H, L. Cool. B, C, D, E, H, L, A, F, S, P. Yeah, it just works. So at least we got registers done as well, which now means we can officially recognize registers, which will help us quite a bit for all of these instruction right here. So increment, decrement, as you can see, they all take registers, and we covered pretty much all the cases except this one. So this is an indirect reference. As you can see, you can either have HL or indirect HL. What that means, I'll get to it eventually to explain that, but let's just take the word for it. And I probably will have to add two tokens. One is the open brace and the closing brace. Yeah, but here, even with pop, this will help. And my doorbell just rang, so let me quickly check what's going on. I'm gonna take a quick break. Hang on. Okay, actually managed to be back before the timer ran out. Sorry. uh, let's see. Yeah, following tutorials is really annoying, especially because things outdate so quickly. But here's the thing, there is no reason why things should outdate so quickly, right? Or update so quickly, rather. Like, that drives me crazy as well. Like how an API gets released, there's one way of doing it, and then you just start following trends or like programming trends and update the API like monthly in some instances, and you're just like, how am I supposed to work with this? And then all these new programming languages have like, you know, all the package managers which update all the packages automatically, and then it's just like breaks all your code, and then You have to waste time going through everything, fixing everything, just because someone decided, oh, doing it this way is nicer than doing it this way, and it's more modern, so I'm doing it that way. It's like, yeah. It is a huge time sink. And actually, in my 10 years in software engineering, I spent a good chunk of time just upgrading libraries and APIs just to follow trends. Because that's what management wanted, right? It sounds good if we use this no API, so let's use it. Does it make sense? Fuck no. But we do it anyways. But yeah. Does that mean I coded access to the CPU, kind of? I mean, registers are kind of access to the CPU, yes. Um, how? Hmm. Yeah, if I start an explanation now, we have to kind of go deep into it, and that will probably take a bit too long. Sorry. But I'll make sure to upload the stream where I explained the CPU stuff soon. Maybe I get to edit it tonight and then upload it tomorrow morning or something. So that should maybe help with an explanation a little bit. But then again, I will explain registers tomorrow and what they are. But yeah, I think that's it for today. I kind of need some food. I'm hungry. Uh, but even though I know the list is still quite long of all the instructions that need to be implemented, but you'll see once we actually get like the building blocks going of reading all the operands, it's just a matter of putting them together like Lego, and then we can just blast through it. So we've actually done a good chunk of work today. Yeah, have a good day as well. Thank you for watching. Bye.